In this video, we explore the Python modules Math and Time. The specification states that students must be able to write programs that use pre-existing or built-in subprograms, so that's procedures and functions. The programming language subset document goes on to list all of the Python modules and their associated subroutines, which you're required to know for the Paper 2 on-screen exam. And in this video, we're going to take a look at the Math and Time module. So in Python, the Math module contains a number of mathematical operations which can be performed with ease using this module. Now notice how we call it the Math module and not Maths. We also typically say Maths or Mathematics in England, but obviously we're using Python here and we have to stick to the correct spelling. So it's the Math module, not the Maths module. The following functionality is supported from the PLS. Now with the Math module, you must make sure to first import it. So at the top of your code, you'd write import math. We've got ceil, floor, sqrt and pi. Let's take a look at them. So let's start with math.ceil, S-E-I-L. So you can see we've imported the math routine at the top line of our code and we've set a variable x to be 33.7. So .ceil returns the smallest integer not less than r, so the parameter you've passed in. So if I say math.ceil x is 33.7, but the smallest integer not less than 33.7 is 34, and that's what gets returned to the screen. Math.floor, on the other hand, returns the largest integer not greater than r. So we've got math.floor and we've passed in our variable x, which is 33.7. Well, the largest integer that's not greater than 33.7 is 33. So you can see how these two commands are subtly different. Math.sqrt simply performs the square root of the value you've passed in. So math.sqrt 9 returns 3.0 because 3 is the square root of 9. And finally, the mathematical constant pi can be extracted at any time and used in a calculation by doing math.pi. So if I do print brackets math.pi brackets, you can see it prints the value of pi to the screen. Just as we've seen with previous videos, there's nothing stopping us combining different functions from the math module. So here I've got math.sqrt9, which we know returns 3, and then we're timesing that with math.pi. So it times is 3 by 3.141, and you can see the output on the screen. You also need to be aware of the following single piece of supported functionality from the time module. Just like the math module, to use it, you have to use the word import time at the top of your code. The category goes time.sleep, open brackets, and then you give a number in seconds and close brackets. When you do this, the current process is suspended for the given number of seconds, then resumes at the next line of the program. So here you can see we've imported the time module, and then we've printed to the screen first message now count to 3 ... and that gets displayed to the user. We then hit time.sleep bracket 3 bracket, and the program will now pause and appear to do nothing to the user for 3 seconds. As soon as 3 seconds has passed, it will then execute the next line of code, which is, and now here is my second message. The program will immediately continue by displaying countdown from 10 ... And now we're entering a for loop that says I in range 9 to 0 minus 1. So that means starting at 9, going to 0 and stepping backwards through the loop, going down each time. And each time around the for loop, we're going to sleep for 1 second and then print the contents of I. So if you ran this program, you would see countdown from 10, and then every second on the second, it would print 9, 8, 7, and so on. Here's a summary of the math and the time module with the descriptions. Pause the video and take some notes. So that's the theory content of the video covered. We're just going to spend a little bit of time talking about the programming language subset. If you've heard this before, you can skip the rest of this video. Otherwise, it's definitely worth a quick watch. So the exam board at EDEXCEL have released a document that they call the programming language subset, which you can see here on the right. This document specifies which parts of Python 3 are required in order that the assessment can be undertaken with confidence. Students familiar with everything in this document will be able to access all parts of the Paper 2 on-screen assessment. The exam board will not go beyond the scope of this document when setting you any questions in the Paper 2 exam. Any students who do successfully use more complex methods, which are not included in the document, will still, however, be awarded marks. Further to this, you will see here from the front of the exam paper that you are actually going to be supplied with a printed and an electronic copy of the PLS during your Paper 2 exam. Well, if this document outlines everything you need to know in order to program in Python during the exam, and you can be guaranteed that you can answer all the questions using all the techniques in this document for full marks, then you might as well get used to using it now. Ask for a copy from your teacher and have it as a reference guide at all times throughout your GCSE course. It will be invaluable.